Hey guys, welcome back to another Roblox video. So the last two videos we were talking about three-dimensional shapes and their areas, so we're going to continue on that. And our topic for today is going to be pyramids, specifically regular pyramids. So if you didn't know, then a pyramid is kind of like a prism in that it has a base. But while a prism has two bases, then a pyramid only has one base. This orange shaded in area right here is the base, and it has one vertex. So basically, the second base is only one point, and that point's right there. That point is called the vertex. And n lateral faces connect the edges of the base to the vertex. And n equals the number of sides on the base. So each of the lateral faces is a triangle, as you can see. So I made another model. This is a square pyramid, so this is the base, and you can see that as I turn it, each of these lateral faces is a triangle. So a regular pyramid is a pyramid that has a base that is a regular polygon, so all the angles are congruent and all the sides are congruent, but that's not the only thing that makes a pyramid regular. For example, this pyramid right here has a square base, but it's not regular because the second criteria is that the altitude, which is the perpendicular distance from the vertex to the base, has to intersect the center of the regular polygon. So right here you can see that the altitude on this pyramid would be outside of the base. It'd be right here. So it's not intersecting the center of the regular polygon. And right here, this is a rectangle, and rectangles don't have a center. So this can't be a regular polygon either. So, but right here, this is a hexagon, so it's a regular polygon, and the altitude, the perpendicular distance from the vertex to the center, it intersects the center of the hexagon, so therefore this is a regular pyramid. It's a regular hexagonal pyramid. So let's go on to some of the area formulas. So, as I showed you, this is the model, and I'm going to be describing it over here as well. So in order to find the lateral area of a regular pyramid, or the blue area right here, or the white area right here, then you need to follow the formula 1/2 times P, which is the perimeter of the base, times L, which is the slant height. And the slant height is another dimension on a pyramid. All pyramids have them, but only regular pyramids have a consistent slant height. The slant height is basically the perpendicular distance from the base edge to the vertex. So it would be this distance right here, all the way from this base edge and all the way up to the vertex, and it would be perpendicular to the base edge. So on a non-regular pyramid, or an oblique pyramid, then this slant height would not be consistent. It would be different on this side than it would be on this side. But on a regular pyramid, then all the slant heights are congruent. And the reason why the formula is 1/2 times perimeter base times the slant height is because you're basically finding the sum of all the triangles. That's what the lateral area is. It's just the sum of all the triangles. So if I were to cut this open, then you would see that the lateral area, it consists of these 4 triangles. So since the slant height would be the height of these triangles, so if I fold it back up, then you can see that the slant height, which is the perpendicular distance from the base edge to the vertex, is just the height of one of the triangles. You're basically finding 1/2 times one side length times the slant height, which is the height of the triangle, and you're multiplying that by the number of sides. And so you're multiplying this by the number of sides. And since the number of sides times each of the side lengths is equal to the perimeter, what you end up with is basically 1/2 times the perimeter times the slant height. And the surface area is basically the lateral area, which is 1/2 times perimeter of the base times slant height, plus the base area. So here it would be the area of this square. If it's a square or an equilateral triangle, they have their own special formulas. If it's any other regular polygon, you can find the area of that using the formula 1/2 times apothem times perimeter. So let's do one practice problem, because again, most of these involve straight plugins. So here, it gives us a hexagonal regular pyramid, and the altitude is 10 and the base edge is 6. So we're going to have to use some of the sine, cosine, and tangent in order to find, for example, the slant height, and then we're going to have to use that to find the surface area. So first of all, we need to find the slant height in order to find lateral area, which is 1/2 times the perimeter of the base times slant height. So we need to first find what the slant height is. So in order to find the slant height, we would need to find first the distance from the center to the midpoint of one of these sides, since it would form a right triangle that looks like this, and then you could find the length of the hypotenuse, which would be the slant height. So in order to find this distance right here, we need to use sine, cosine, and tangent. So let's form this triangle right here. Since this angle right here would be 30 degrees, since it would be half of the central angle of a regular hexagon, which is 60, then this means that this is a 30, 60, 90 triangle. And half of the base length would be 3, since this segment right here divides the base edge into 2. You could use the special rules for a 30, 60, 90 triangle to find that the apothem is 3 square root 3. Since, as you know, the sides of a 30, 60, 90 triangle are 1, 2, and square root of 3. So now you can use the Pythagorean theorem. So 10 squared plus 3 square root 3 squared ends up with your hypotenuse. So I'll just do that on my calculator. And we find that the hypotenuse is 11.27. So now we have our slant height, and we can just plug in to find the lateral area. The perimeter would be 36, and 6 times 6. And we find that our lateral area is 202.85 units squared. So that's our lateral area. And now we just need to find the surface area. And the surface area should be easy, since over here we already found our apothem. We can just use our knowledge that the area of a regular hexagon is 1/2 times apothem times perimeter. So surface area is base plus the lateral area. And we know that the base is 1/2 times apothem times perimeter. And we just need to add our lateral area. So we would just substitute in what we learned. We learned that the apothem is 3 square root of 3, and the perimeter is 36 from up here. So if we plug all of that in, we get 296.38 units squared. And that's basically how you find the lateral area and the surface area of a regular hexagon. Sometimes if the base is a square, then it's easier to find the base area, and the lateral area will be easier to find because you can just divide the side length by 2 and then use that to find the hypotenuse of the right triangle. But if it's any other kind of regular polygon, then you're going to need to use your trigonometric functions and 1/2 times apothem times perimeter to find the areas. Good stuff.